Hello everyone. Imagine a uniformly charged spherical cell, and the question is, what is the electric field inside the cell at any point? The answer to this question is 0. Then question is why? This result is surprising, no doubt, but why? How this is possible? Now you consider Gauss's law. You know Gauss's law in electrostatics. According to that law, the total flux through any closed surface is proportional to the enclosed charge. That is the Gauss's law in electrostatics. And now use that law to explain the result. To analyze the problem, use that law, Gauss's law. So inside the cell you consider any point and enclose that point by an imaginary surface called Gaussian surface. Now you ask, what is the enclosed charge by that Gaussian surface? Answer to this question is 0. Inside the cell there is no charge. So whenever you are you are covering a point by a Gaussian surface, then in that case the enclosed charge is 0. So according to Gauss's law, total flux through that surface is 0. Therefore, electric field is 0. So we can use Gauss's law to explain the result. Again, if you consider the symmetry of the problem, then also you will get the same result. How? You just imagine placing a test charge inside the cell. Inside the spherical cell, you just place a test charge. Not practically, just imagine. Now you consider the forces on that test charge by the charges which are present on the outer surface of the cell. So you can see that in that case, for any force on the test charge, there is an equal and opposite force. Because it is a spherical system we are using here. Means spherical symmetry exists in this case. That's why on the test charge, for any force, there is an equal and opposite force. That means these two forces are cancelling each other. Same way, if you consider all the forces for all the charges on the outer cell, then you can see that all the forces are cancelling each other. For all the forces, there is an equal and opposite force, and they are cancelling each other. That's why. And so net force becomes 0 at the location you are considering. So since net force is 0, that means electric field is 0. Okay. Net force is 0, that means electric field is 0. Because electric field is actually defined that way. In an electric field, if you place a test charge, then the force experienced by the unit test charge is known as the electric field at that location or at that point. If the charge is having the amount q, okay, magnitude q, then in that case what happens? Say force experienced by that charge is F, then in that case per unit charge, what is the force? F by q. So that F by q, that ratio means force experienced by only unit charge, that is the electric field at that point. And direction of the force is the direction of the electric field. You know electric field is a vector quantity. Direction of the force itself is the direction of the electric field. Okay. So similarly here also, to explain the same thing, we have used the concept of symmetry. For any force there is an equal and opposite force, and that way the net force on the test charge becomes 0, and that's why electric field at that point becomes 0. So both by using Gauss's law and by using the principle of symmetry, we can reach to the same conclusion. Anyway, so this was all about today's topic. Topic was what? Electrical cell and electric field. And there was actually a question. And answer to this question is 0. Anyway, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.